Okay, this question is interesting because at the end here, we are supposed to prove that this angle here, the angle between these two bond here is 109.5 lah. Okay, theoretically. So we can do that. Okay, so the first thing is, of course, as usual, we need to understand how do we go about understanding this question here. So as usual, okay, this is good because Q, R, and S, the coordinates are given. So this is 8118, and this is 872, and S is 21212. Okay. So respectively form an equilateral triangle. So this is equilateral triangle. The base is equilateral triangle. Find the Cartesian equation of P which contains QRS. I think that one is okay. There's 4 marks. So meaning we actually want to find this base here. Okay, so we want to find the base there. The base area there lah. So Cartesian equation, I think it's not that difficult. Eight one eight. R is 872. S is 212. Oh, this is quite easy. Okay, so the normal of the plane, if of course QR cross with QS, it doesn't matter which one you take. It really doesn't. So this case here, QR will be 806 872, right? 87. Will be 806 cross with 2016. Okay. You can factorize if you want to, but I will just factorize the 6 out. Minus 6. Actually, this doesn't matter. This scalar don't really care. You can just put the negative 36 outside, and what you want is actually just these two cross together. Okay. One way is you can just ignore the negative 6. You don't need the scalar product, because cross product, we just need the direction vector. So you can just ignore. Okay, but if you get it in also can. The reason why I'm doing this is because I don't have my calculator, or rather I lazy to use my calculator. So I'm just going to evaluate this cross product here. It's more than enough. Okay, so this is my normal. Cross them. 1 0 minus 1 1 negative 1 0 minus 1. Hope that's normal there. This part here, how to check your normal is correct. You just substitute all the values in. So n dot r equals, I use Q, I also use R 872. I think from my past experience, the past question which I never tried 3, right? Then I got wrong, so I might as well just try 3 of them. 8. This would be minus 1. Will also be minus 1. Hence, in scalar product form, R dot QRS. There you go. So for part 2, find the Cartesian equation of P1, which passes through the midpoint QR and perpendicular to QR. Okay, great. So if you think about it, right, if this is okay, try and draw it in. I'll try my best to draw it out. So midpoint will be roughly here. I hope you can see the midpoint is roughly here. Midpoint, right? Okay. Then you want a plane which is like cut through here. Like that. It cuts through. Let me draw it out for you. like that. I hope you can see it. It cuts through like that. It may not be easy to see. That in the middle. They say it must be perpendicular to the plane QR lah. Maybe I draw it nicely, yeah. Okay. So you want the plane to be perpendicular in this sense. Just try to understand. So meaning if you simplify this, okay, P2, okay, so P1 passes through the midpoint QR and is perpendicular to QR. So meaning to say the normal, this is P2, right? This is P1. The normal of P1 is actually parallel to QR. Okay, the normal is just this this one here. Normal of 1, right? So you're looking at this this here. So if you want to simplify the question, what you can do is you just put a PR here. Maybe I just draw a plane like that. Maybe then this is a midpoint. So this is P R P QR, sorry, QR. This is midpoint. Midpoint. I just let the midpoint be M. Then perpendicular. And then this is your plane 1. Okay. That's about it lah. So Q is actually 818. R is actually 872. Okay. Let M be midpoint of QR. Okay. So M will just be 8 plus 8 divided by 2, comma, 1 plus 7 divided by 2, comma, and 8 plus 2 divided by 2. It's just midpoint theorem. So this will be 8, 7, 8, 4, 10, 5. Okay. The midpoint. The normal of P1 and 1 would just be QR. Okay. QR we found just now. QR was 0.606. Okay, or 0.1 minus 1. Okay. Hence P1 just use 8.4 because it's 8. This is a point. They want a Cartesian form. Yeah, okay. So this is hence. Yeah, there you go. So part 3 is just 1 mark. You are supposed to find the line, the intersecting line, right, between P1 and P2 meets. So P2 is this equation here, x plus y equals to 9. So P2 is equals to plus y equals to 9. You just use calculator lor. So part 3, what you need is actually just 0x P1. Just use calculator because it's only 1 mark. 1 mark meaning they can't give you method lah, so you don't need to use it. Okay, so from GC, in calculator, equation simultaneous equation 2 equations, 3 unknowns. clear it first. It's 0, 1, negative 1, negative 1. So 0, 1, negative 1, negative 1, 1, 1, 0, 9. Okay, off. There you go. There you go. The vector line equation here is x equals to 10 minus lambda, y equals to minus 1 plus lambda, z equals to 0 plus lambda. Okay, so the line L r equals to 10 plus lambda. Have I used lambda previously? I don't think I did. No, so this is uniquely this line. Yeah. I think it's 1 mark. Typically in exam, I think it's 2 marks. For part 4, we try to understand what is P2. P2, right, is another plane. So I'm just going to draw another plane here. Can you see that P2 intersect at T here? So like, if you draw a P2 out, right, it looks like that. Let me just use another color here. Because it cuts through here. Right. So maybe this plane cut through here. Here. Yeah. Okay. Yeah. Yeah. So I hope you can visualize this. This is my P2. So they are telling you that actually T lies on the line equation. This line equation here, actually we found it lah. We here, this is the line equation. The one that we found is this line. So this line in the middle, this is what we found just now. Okay, try to understand what the question is describing to for you. So then you don't need to double work or anything. Just try to understand them. Okay, so this is P2, right? This P2 is midpoint between RS and yeah, passes through the midpoint perpendicular. So this is L. This guy is L, which is true because if you look at this diagram here, it will be L, right? So the point T is on L, such a QRC is a regular tetrahedron, where QR is equal to QT. Okay, so this length here is the same as this length here. So we know lah. Show that possible coordinate for the point T is a possible coordinate is this one. Now, first of all, you must understand that T got 2 possible coordinates because if this is T here, there's another T which is possible is below. So that's why there are 2 possible coordinates, right? One is on top, one is below. Okay, so that's about it lah. QR equals to QT. I think this is pretty okay. QR equals to QT. So what I'm gonna do is find the length of QR equals to QT. So OT will take the line equation L. I'm gonna do this part 4. Maybe I do another page. Hold on. For some lambda is real value, OT is actually equals to this is T, OT. So we know that QR equals to QT. QR is 0, 6. QR equals to QT minus modulus QR is equals to modulus QT. Yeah, QR we found just now. QR 0, 6, negative 6. Okay, then QT OT minus OQ. OQ is 818. Then this is yep, there'll be 36 times 2, 72. Then okay, maybe I should just rearrange this one. $72. Is it? 3 lambda square 4 plus 4 plus 64 minus 2. Oh, amazing. So lambda equals to 0. Possible position. Okay, then 0 sub back in. 10. 10 minus 1 0 plus 8 minus 1 1. So it's 10, which is 2 7 8. Shown. Okay. These are the two possible position for T, right? Just now at the start, I say what? I said the two possible position is essentially if you have a tetrahedron like that, the bottom T is here, ma. This is the second T. Right, this is the second one, right? Alright. So in other words, if you want to find this point here, you want to find this point, right? You want to find the coordinates of a point P closest to T, right? It's actually this point here, right? Alright? It's actually the midpoint between this point and this point. So the hence part, actually, you just need to use midpoint theorem. Okay, that's the fastest way. But of course, the otherwise part is you just go and find you intersect L with the plane, you get the answer lah. But the hence part is essentially you must understand that these two possible position, one is on top, one is below. You just basically just find the midpoint. Okay. So what I'm gonna do is the coordinates of point P, hence point, hence coordinates point on P closest to T 278 plus 10 minus 1 0. This is 12. Okay. Wait, they want the coordinates, is it? Coordinates, so I should write down the coordinates. Maybe I redirect it. Alright, so this one, hence method. So the coordinates. So we try to understand, given that TV is three quarter of the total height. Okay. So this is the total height. This one, right? This is the total height here. Total height is here, right? Okay. So we already found this point here. This point, just the previous part, we found this point here. This point is what? Point here. This point, middle point here is actually 634. All right. So you're told that actually TV is three quarter of the total height. So find the coordinates of V. Okay, let's just deal with the first one first. Find the coordinates of V. So I'm going to show you how you can reduce this. Because now we know that the bottom part here is actually 634. Okay, so I'm going to let the F, any coordinates F? No, right? No, F be 634. So here, the floor lah. I put F because it stands for on the floor. So here, this is F. Then after that, I got a V in the middle here. And then T here, which we got the coordinates of T. Coordinates of T was 278. 34. I use a column vector. Okay, so now this is what's going on. This is total height. Okay, and essentially what we are dealing here is we are saying that TV is 3 quarters. So this is 3 is to 4. The total height is 4 units. So this guy here will be 1. From here, what I can do is actually just going to find the what do you call it? The using ratio theorem. Okay, so use ratio theorem to find what is by V. So here, by ratio theorem, OV is equals to the middle guy is always the subject. So OV is OF multiplied by 3 plus 1 multiplied by OT over 4. We want to find, oh great, this is like 3, 4. OT is what? 278 over 4. Calculate everything out, should be the answer. 9 plus 7, 16. 12 plus 8 is 20. I really hope that's the answer, man. It seems like it. This is 5, 4, 5. They want the coordinates, is it? Coordinates. Yeah. Coordinates for V is actually 5, 4, 5. Okay. Okay. hence because now we already found the v the position vector of v already, so we want to show this angle here. So it's just a regular dot product, but take note, this is an obtuse angle, guys. This is obtuse. People, girls, obtuse. This is obtuse. Obtuse meaning when you do it right, you try don't mod it, okay? Don't mod it, and then the direction matters now because it's important. So here, if it's obtuse, you're pointing outwards like that. If this is v is 5, 4, 5, and then the top part is E here is actually 2, 7, 8, and this part here is actually Q. Q would be 818. Okay, so when it's obtuse, just make sure that if this is coming out, just go out together. I think usually what I do is a good habit to just point the vectors out from a point, or if you want to point in, both have to point in also. Okay, just don't do this one go in, one come out. Okay, it doesn't work that way. So just make sure it's just so actually it's okay lah. So VT is VT and VQ. I dot these two. Okay, so VT would be T minus V. So minus 3, 7 minus 4 is 3. 8 minus 5 is 3. I can actually just okay, maybe not. Should I? Okay, never mind. I want to divide by positive 3 lah, but I shouldn't do that because later I scared you're confused. Okay, so Q 3 minus 3 and 3. Good job. So hence theta, okay, cosine theta, or rather VT dot VQ. Okay, don't mod it don't mod it because now obtuse angle. You don't mod it, so cosine theta dot with 3 square. 3 square. This will be 27 root 27 minus 9 angle PVQ. Okay. Uh, 5. Okay, there you go.